So today I'm going to explain how to get a Bode diagram for the phase of a transfer function. So first, when we're creating Bode diagrams, we want to get the transfer function in this form: 1 plus s over omega n to the n power. Omega n is your point where a decade below and a decade above the phase is going to change, the phase slope. So you're probably asking, well, how can I get this into that form? Well, we know that 1 over 1 plus 2s is the same thing as 1 over 1 plus s divided by 2 to the negative 1. And 2 to the negative 1 is just 0.5, because it's 1 over 2, which is 0.5. So that means we have 1 plus, this is a different thing that I'm going to talk about later. Just ignore that for right now. This simplifies to 1 plus s divided by 2 to the negative 1 to the negative 1 power, or 1 plus s over 0.5 to the negative 1. Hopefully this makes sense. If it doesn't make sense, go back to study the exponents and understand the math behind it. So you see now how this is in the correct form. We have the 1 plus, and we have the s divided by a value to the negative 1 power. Well, now that this is in the correct form, what does this tell us? This is like an instruction. This tells us that this 0.5 is omega n, and this negative 1 is going to tell us whether the slope is going to go up or down. A negative means down, a positive means up. So if omega n is 0.5, what does that mean? That means from omega equals 0.05 until omega equals 5, there will be a phase change. So you're probably wondering, okay, that's great, I know where it changes, but how do I know where it starts? So let's look at this for a second. Remember the hidden 1 in front of everything? There's always a 1 in front of everything, because 1 times anything is itself. So if I wanted to look at the phase of this 1, how would I do it? Well, to get phase, it's the arctangent of the imaginary over real. Well, what is this? What's the imaginary associated with this? It's really 0j, right? 0j plus 1. So that's the arctangent of 0 over 1, which is the arctangent of 0, and the arctan of 0 is 0. That means this graph has to start at 0 degrees. Look at that. So we got our first point. Now, when we're looking at these equations, if there's a 1 plus, that means that it's going to be in a straight line. That line's either going to go up or it's going to go down. If that 1 plus was not there, it would go flat like this and then go up or down at its omega n value, depending on this sign right here. So that's going to tell us the shape of our graph. Since there's a 1 plus, we know it's going to be a line. Now, if we're starting at 0, and we know that the omega n is going to change the phase from 0.05 until omega equals 5. So we have to start at 0 degrees. I'm erasing something I previously wrote down so I can better explain this to you guys. So what happens? Well, we're at 0, and nothing happens until we get a decade below our omega value. So this continues straight. Now, when we get to 0.5, from 0.05 to 0.5, what do? Well, we have to get the phase of our function, so phase of 1 plus s over 0.5 to the negative 1. So something really cool happens here. If we have 1 plus s over 0.5 to the negative 1, you can basically ignore the exponent for now. It's just going to tell you the direction of the line, which we already established is going down. So if you plug in j omega, you get 1 plus j omega divided by 0.5. Well, where are we trying to figure out this value? We want to plug in omega equals 0.5. because that's our omega n. So when we plug that in, we get 1 plus j 0.5 divided by 0.5. So look at that, these two cancel out, and we're just left with 1 plus 1j. From here, how do we get the arctangent? You have to take the arctangent of the imaginary over the real. So that's the arctan of 1 divided by 1, which is just 45 degrees per decade. That means that our slope from 0.05 until 50, or until 5, slope changes by 45 degrees per decade. In our particular case, because the exponent was negative, it's actually going to be negative 45 degrees per decade. So the slope changes by decreasing by 45. From a decade below omega n to a decade above. Sorry that I'm running out of room here. Hopefully that makes sense to you guys. So if I'm at this point, I kept going straight because nothing happened, and now I'm at a decade below my omega n. We established that there's a slope of negative 45, which means our line is going to go down with a slope of negative 45 right here, and it's going to keep going with the same slope of negative 45 until this point. What happens at this point? Well, it has no effect. So it continues at whatever level it is at after that. Keeps going straight. Hopefully this makes sense to you guys. Let me know if you have any questions about it. You're probably wondering, when you look at this, what would happen if I multiplied by something else, like 1 plus s over 5 to the 1 power? What would happen? Well, 5 is our omega n, and we know that's going to cause a slope change from a decade below, which is 0.5, until a decade above, which is 50. And we see a 1 here, which means it's going to increase the slope by a certain amount. What is that amount? Well, we do the same thing. We plug in j omega, so we get 1 plus j omega divided by 5, and then the omega value that we have for this is 5, so we plug it in, and it cancels out. So we're left with an increase in slope of 45 degrees. If we combined that with our previous problem, what would that do? Well, that would mean that from 0.5 until 50, we would have an increase in slope of 45 degrees. So right now, from here to here, this is a slope of negative 45. If I add 45 to this, what's my slope? Well, it'll be 0. So if I add 45 to this is going to flatten out like that. And then I still have an increase of 45 until I get to 50. So what's 0 plus 45? Positive 45. So this graph, and then after this point, everything stops and it just continues along its happy way. So it's going to look like that if I were to multiply by the extra box value right here. Hopefully this makes sense to you guys. Just to reiterate, the reason that we started at 0 degrees was because of the hidden 1 in front of everything. The arctangent of 0 over 1, which was 0. Technically speaking, I am pretty sure that you can get the arctangent of 0 also to equal to 180. Confirm me on this, like check that is true, that the arctangent of 0 is both 0 and 180. But if that is the case, then you should also be able to start at 180. Start the graph at 180 and go through the same exact process. Hopefully this makes sense to you guys. Let me know if you have any questions, and let me know if you have any example problems you want me to do. Thanks for watching.